as a project manager or as an engineer, you will be given a table that describes a list of activities that are within your project and the dependencies of each activity on each other, as well as the duration of each activity. So I've got a table in the top left here that's going to give us something to play with. And so the very first thing that we're going to be doing is just looking at the dependencies of our project to scope out where are these nodes going to be relative to each other. We're going to be drawing these vectors that have, showing us the dependencies. And so in our case, what we see is that we've got activity A being the first thing in our project, and activity A has no dependencies, and then we've got activity B. And so because activity B depends on activity A, we will draw our arrow going from A to B like this. If we now look at activities C and D in our table, we will see that both of these activities depend on B. So I'm going to draw activity C and activity D like this, and then there's going to be arrows pointing from activity B to both activities C and D as follows. Next, when we look at activity E and F, we're going to see that E and F also both depend on C. So I'm going to draw activities E and F like so, and then we're going to have another two arrows from activity C to E and F like that. Next, we're also going to note that we've got activity G, and activity G is going to be right here, and activity G, because it depends on activity D as well as activity F, we're going to have these two arrows pointing to it like that. Next, we're going to have a final activity H, and activity H is going to depend on activity G as well as activity E. And so this is what our node structure or our network structure is going to look like for our scheduled network diagram. And so the next thing they're going to do is make note of the duration days for each one of our activities. And so this is where we're going to build our real scheduled network diagram using these little 2x3 matrices that I've drawn here. And so in this case, I've already filled it out with the structure that we just derived above. And in each of these, we're going to note that the middle column contains the activity and the duration. So I've pre-filled all this out because that's all tabulated. And now what we're going to be doing is the forward pass in order to determine what is the project duration of our project. And so we're going to assume that we start on day 0. So I'm going to put a 0 right here in the top left row of the activity A. And what we're going to do is say that on day 0, if I let A start, and we know that A lasts for 2 days, then I know that the early finish date for activity A is going to be day 2, because 2 equals 0 plus 2. So we're kind of doing this little diagonal like that. Next, if we know that activity A finishes on day 2, that will be the early start date of its dependent activity, which is activity B. So I'm going to put a 2 right here. We know that activity B lasts for 1 day. So if it started on day 2, went for 1 day, we know that the early finish date of activity B is going to be day 3. If we know that B finishes on day 3, that means that our dependent activities C and D can both have their start date on day 3. So I'm going to put a 3 in the top left row for each of these activities. We know that activity C goes for 4 days, and therefore activity C will have an early finish date of 7 on day 7. And then activity D, starting on day 3, going for 5 days, is going to end on day 8. And because we know that E and F activities depend on the finish date of C in our early finish scenario, that means that the early start date of activities E and F will also be day 7. So I'm going to put a 7 right there. Now, what we're going to do is we are going to determine the early finish dates for activities E and F. That's going to be 7 plus 3 for activity E, which is equal to day 10. And then for activity F, that's going to be 7 plus 2, which is equal to 9. And so I want to draw your attention here to activity G, because we don't necessarily know what is the start date for activity G, because we've got two options here. We know that G depends on both activities D and activities F, but we've got two different dates, because activity F is finishing on day 9 on the earliest date, and then activity D is finishing on day 8 at the earliest date. So what this tells us is that because we can't go backwards in time, the earliest date that activity G can start must be day 9, because I don't care how early D finishes if it's not earlier than the other dependent activity. So activity F is basically blocking activity G from starting on day 8 in this particular scenario, which is called our forward pass. So the earliest we can possibly start activity G is on day 9, and then following this, if we add 9 plus 6, because we know activity G is running for 6 days, that means G is going to be finishing on day 15. And again, we've got this predicament of what is going to go into the early start date for activity H. We've got an option between day 15 and day 10. In the case of our forward pass, this means that we're going to have to go with what is feasible here, which is going to be day 15, because on day 10, activity H is being blocked by activity G because G has yet to finish. And then finally, if our activity H is running, it started on day 15, goes for 3 days, we know that it's going to be finishing on day 18. So this is our project duration. So if someone came to you and they said, based on this table, what is the duration of our project? It's going to be 18 days based on the logic that we just performed in our forward pass. Now what we're going to do is determine our critical path, which we'll describe in more detail later. But to calculate the backward pass to get that critical path, what we're going to do is we're going to take this finish date, our early finish date, and assume it's our late finish date. And so we're going to put an 18 right here. And now what we're going to do is we're going to say that for activity H, if it finished on day 18, we know it lasted for 3 days, it must have had that late start date of day 15. And so now for the two dependent activities on day, for activity H, or activity G and activity E, we're going to stick this 15 into these two rows right here. So we're going to have a 15 and a 15 right here. And so looking at activity G, if G finished on day 15, lasted for 6 days, that means that it must have finished, or must have started, sorry, on day 9. And then for activity E, if we know that E finished on day 15 and it lasted for 3 days, that means that it must have started on day 12. Okay, and so now what we have here is the following. So if we know that activity G started on day 9 and F and G were the two dependencies of activity G, that means we're going to stick this 9 here for our late start into the late finish dates for activities F and D as follows. So I've got a 9 right here and a 9 right here. And then what we're going to do is we're going to apply the same algorithm and basically work backwards. So 9 minus 2 means that activity F must have started on day 7 in our late scenario. And then activity D, if it finished on day 9 and it lasted 5 days, must have started on day 4. And now what we're going to do is we're going to look to activity C, and we're going to see that activity C here is going to be when is its late finish date if we have an option between both 7 and 12. And so for 7 and 12, we're going to do the opposite from what we did in our forward pass. We're going to now say that we're going to pick the smaller of these two numbers. And now, because we know that activity C finished in the late scenario on day 7, lasted for 4 days, that means its late start date must have been day 3. And now, again, we're presented with this predicament of 4 and 3 for the late start dates on the dependent activities for B. And we're going to go with the smaller again. So we're basically saying that for activity B, its late finish date in our backward pass is going to be 3. 3 minus 1 equals 2. And then because we've only got one dependency for A, in this scenario, we're going to put the 2 right here. 2 minus 2 is equal to 0. And so now we've finished drawing our diagram in the backward pass scenario. Now, the question is, what is the critical pass? Because we just finished this. So what is the critical path? And so in our case, the critical path is going to be the one in which we're seeing how the early start date must be the late start date for us to get to our project duration. So we're seeing this here in activities A, activities B, activities C, F, G, and H. And therefore, what this tells me is that our critical path in this scenario is going to be the following. So I'm just going to draw around this, trying to keep it clean. Our critical path is going to be A, B, C, F, G, H. And what this tells us is that if any of these activities on our critical path is delayed, it will directly impact the project duration. So if activity C, for instance, was delayed by 1 day, that means that our project duration is now going to get 1 day longer. So basically, every single activity on your critical path you want to make sure is not delayed, because if it is, it directly affects when your project will finish, if you want to finish your project on time or under budget, for instance. And so in this case, what it also tells us is that in activities E and F, just want to draw a focus here. If we look at these activities, E and D, what this is telling us is that we can, in theory, let project E, in the worst case scenario, start at day 12 and still be on track to finishing our project on time. So that's telling us we've got some float here, which we're going to describe in another video. And also for activity D, because D is not on our critical path, we can let D, in the worst case scenario, start at day 4, and it still will not affect our project duration. So that's going to wrap things up for this video. We were able to successfully define the critical path of our project, which is basically telling us, again, what activities need to be completed on time to not affect your project deadline or your project finish date. And then we've also determined what is the project duration from the tables that we've just drawn here in our schedule network diagram. So I hope this video helps. Let me know if you have any questions. Thank you all for watching, and I'll talk to you all next time.